Studies Section 5, Descriptive Statistics 1. Introduction. In this lecture, we want to examine how numbers can be employed to describe and explain human social condition. Political scientists and political practitioners frequently employ symbols such as percentages, rates, averages, and deviations to measure politically significant phenomena. This lecture will attempt to equip the student with the skill of supporting their argument with numerical facts and figures in reaching out to their audience. Objectives. At the end of this lecture, students should be able to 1. Compute simple averages, percentage, rate, etc. 2. Use and interpret these numerical measures accurately. 3. Do better comparative studies using the descriptive statistics as a tool. Pretest. To be taken before you read this lecture. 1. The total annual budget for 2001 was 500 million naira. Education was allocated only 25 million naira. What percentage of total budget goes to education? A. 50%, B. 0.5%, C. 500%, D. 5%. 2. 16 million people voted in the 1993 presidential election, while 24 million people voted in the 1999 presidential election. What is the percentage change? A. 5%, B. 50%, C. 0.5%, D. 500%. 3. Calculate the average income of 4 students whose individual income are 5, 8, 10, 9 in thousand naira. A. 80,000 naira. B. 8,000 naira. C. 800 naira. D. 800,000 naira. 4. The value that appears most frequently in a distribution is known as the A. Mode, B. Median, C. Mean, D. Variance. 5. One single value is typical of its group is known as A. Mode, B. Median, C. Mean, D. Variance. Content. Section 1. Percentage, rate, and ratios. Okay. Content. Section 1. Percentage, rate, and ratios. Percent literally means out of 100. Let us illustrate this concept by the first question in the pretest exercise. Solution to pretest 1. Percentage is equal to value of interest over total value times 100%. Education is equal to 25 times 100% over 500, which is equal to 5%. Thus, in intersectional budget comparison, it is much more appealing to say out of the total government budget, 5% was allocated to education, while 24% was allocated to defense. Irrespective of what currency you are working with, your reader or listener will have a clear picture of your argument. Note that in our computation above, the naira unit cancels out. Solution to pretest 2. Percentage change is equal to final value minus initial value over initial value times 100%. 24 minus 16 over 16 times 100% is equal to 8 times 100% over 16 is equal to 0.5 times 100% is equal to 50%. Note that the percentage change in the number of voters is positive here. In some other cases, it could be negative, that is, if the final value is lower than the initial value. Rates. Let us also illustrate this concept with a clear example. Answer this question before you proceed. Question. From the table below, which country has the highest crime rate? Country: Nigeria, Ghana, South Africa. Population: 120 million, 52 million, 40 million. Number of crime in 2001: 10,000, 3,500, 8,000. Solution: if your answer is Nigeria, then you are wrong. It is wrong to say Nigeria had the highest crime rate simply because the number of crimes recorded in Nigeria is greater than the two other countries. That is, an operational definition relying simply on the number of crimes committed in a year is invalid. Large countries have more crimes simply because they have more people. The correct thing to do is to express the number of crime cases per 100,000 population. That is, Nigeria is equal to 10,000 times 100,000 over 120 million is equal to 10 times 100 over 120 is equal to 8.3, approximately 8 crime rate per every 100,000 population. Ghana is equal to 3,500 times 100,000 over 52 million is equal to 350 over 52 is equal to 6.73, approximately 7 crime rate per 100,000 population. South Africa is equal to 8,000 times 100,000 over 40 million is equal to 800 over 40 is equal to 20 crime rate per 100,000 population. Therefore, South Africa has the highest crime rate per 100,000 population because 20 is greater than 8. Ratios. Unlike in percent and rate, ratios are computed by dividing non-equivalent units. For example, per capita gross nation product is equal to GNP in Naira over population number of people. Thus, nations with higher per capita GNP can be said to be more economically developed than nations with low per capita GNP. Section 2. Measures of central tendency. The measure of central tendency attempts to locate a typical value about which a distribution clusters. It represents an average character of the data. The most common measures of central tendency are the mean, the mode, and the median. As we have learned in Lecture 1, there are grouped and ungrouped data. So also, there are different computation techniques for grouped characteristics and ungrouped characteristics. Therefore, for each concept we discuss here, we shall give the computation technique for ungrouped data separately and that of a grouped data separately. The mean. The mean, sometimes called the arithmetic mean of a set of numbers, is the sum of the numbers divided by their total frequency. This is usually computed at the interval level by adding together each score and dividing the sum by the total number of cases. It is sometimes represented by mean or simply M. For an ungrouped data, mean is equal to sum of all values over number of cases is equal to summation xi over n, where n is equal to total frequency, or summation f is equal to summation is just a symbol for sum of for a group data. Use mean is equal to summation fx over summation f. Here the numerator says Multiply each value of mean by its corresponding frequency and sum all. The denominator says sum together all frequencies. Example: from the given data below, calculate the average mean defense expenditure of Nigeria over the 5 years. Table 5.1. Year: 1995, 1996, 1997, 1998, 1999. Defense expenditure in billion dollar: 5 billion, 8 billion, 10 billion, 9 billion, 11 billion. Solution: since this is an ungrouped data, we use equation 4.1. Mean is equal to summation xi over n is equal to 5 plus 8 plus 10 plus 9 plus 11 over 5 is equal to 43 over 5 is equal to 8.6. Thus, the mean defense expenditure of Nigeria for the period is 8.6 billion US dollars. Now you should attempt example 2 before proceeding to the solution. Example 2. The number of private bills passed in year 2001 by 19 state houses of assembly in northern Nigeria is as given below: 5, 4, 5, 4, 7, 8, 4, 5, 8, 7, 8, 5, 7, 8, 6, 8, 6, 5, 8. What is the average number of bills passed for that year in the north? Have you solved it? Now proceed to the solution provided below and compare your steps and the answer. Solution: since each of the numbers appear more than once, we must multiply the numbers by their respective frequencies, that is, number of times they appear. Thus, using equation 4.2, mean is equal to summation fx over summation f. Average bills passed is equal to 5 into bracket 4 plus 4 into bracket 3 plus 7 into bracket 3 plus 8 into bracket 6 plus 6 into bracket 2 over 4 plus 3 plus 3 plus 6 plus 2 is equal to 20 plus 12 plus 21 plus 48 plus 12 over 19 is equal to 113 over 19 is equal to 5.947. That is, approximately an average of 6 private bills were passed in year 2001. The median. The median is the value that divides a set of observations into 2 equal halves. That is, 50% observation is above and below the median. The first task is to arrange the numbers in ascending or descending order. The next task is to locate the n plus 1 over 2 position of the middle term, which occupies the position if there are n figures. As an illustration, let us find the median of Nigerians' defense expenditure given earlier. Step 1. Arrange in order 5, 8, 9, 10, 11. Step 2. The median occupies n plus 1 over 2 position. That is, 5 plus 1 over 2 is equal to 6 over 2 is equal to third position. Note that n is 5 because we have 5 defense expenditure figures. Step 3. Locate the value that occupies the third position in step 1. The value is 9. Therefore, the median defense expenditure is 9 billion US dollars. Another illustration, assuming in addition to those 5 years, the defense expenditure for year 2000 is $12 billion. Find the median. Step 1. Arrange 5, 8, 9, 10, 11, 12. Step 2. Compute n plus 1 over 2 is equal to 6 plus 1 over 2 is equal to 7 over 2 is equal to 3.5 position. Step 3. Locate 3.5 position in step 1. It is after 9 but before 10. Here values 9 and 10 fall at the middle. What you do is simply add 9 and 10 together and divide the sum by 2. Therefore, median is equal to 9 plus 10 over 2 is equal to 19 over 2 is equal to 9.5. Therefore, median defense expenditure is 9.5 billion US dollars. To calculate median for a grouped data, we use formula median MD is equal to LI plus parenthesis open n over 2 minus summation FBM over FM parenthesis close C, where LR is equal to lower class boundary of the median class, n is equal to total frequency. Sum FBM is equal to sum of all frequencies before the median class. FM, frequency of the median class. C is equal to class width. Note that in order to locate the n plus 1 over 2th position in this case, we shall use the cumulative frequency column. See example 4.3 below for the calculation procedure. The mode. The mode is the category which occurs most frequently. At the nominal data below, the mode or modal category is Christianity, religion, Islam, mysticism, Christianity, others. Number of respondents 17, 4, 25, 3. It will be wrong for you to say the mode is 25, which is just the frequency of the modal category. Another example, the mode of the set of figures 7, 3, 2, 1, 7, 5, 7 is what? Answer, mode is 7 because it occurs more frequently than all other figures. Note that if another figure, say 2, occurs as frequent as 7 in the example above, we say the set is bimodal, that is, mode is equal to 2 and 7. For a grouped data, we use the formula mode. MO is equal to LI plus parenthesis open delta 1 over delta 1 plus delta 2 parenthesis close C, where Li is equal to lower class boundary of the modal class. Delta 1 is equal to modal frequency minus the frequency just before it. Delta 2 is equal to modal frequency minus the frequency just after it. C is equal to class width, size. See the illustration in example 4.3 below. Example 5.3. A referendum was conducted in all the 20 wards of the Bakassi Peninsula to determine where the people would like to belong, Nigeria or Cameroon. The number of participants in all the wards are given below: 43, 49, 39, 25, 48, 54, 43, 42, 45, 47, 51, 60, 68, 34, 38, 59, 31, 27. Using a class interval of 21 to 30 etc. 1. Prepare a frequency distribution table. 2. Calculate the mean, mode, median participation. 3. Which of the values in 2 above best describe the number of participants? Class 21 to 30. Tally 2. Frequency 2. Class mark X 25.5, fx 51, class boundary 20.5 to 30.5, cumulative frequency 2, class 31 to 40, tally 5, class mark x 35.5, fx 177.5, class boundary 30.5 to 40.5, cumulative frequency 7, class 41 to 50, tally 8, class mark x 45.5, fx 364, class boundary 40.5 to 50.5, cumulative frequency 15, class 51 to 60, tally 4, frequency 4, class mark x 55.5, fx 222, class boundary 50.5 to 60.5, cumulative frequency 19, class 61 to 70, tally 1, frequency 1, class mark x 65.5, fx 65.5, class boundary 60.5 to 70.5, cumulative frequency 20, total frequency 20, summation of fx 880. 3. To calculate the mean, we use equation 4.2. 4. Since this is a group data, mean is equal to summation of fx, that is sum of column 5, over summation of f over sum of column 3 is equal to 880 over 20 is equal to 44. Thus, the average number of participants at the referendum is 44 people. To calculate the mode, we shall use equation 4.4. Mode is equal to Li plus parenthesis open delta I over delta 1 plus delta 2 bracket parenthesis closed times C. The modal class is the class 41 to 50 because it has the highest frequency. Therefore, Li is equal to 40.5, see column 6. Delta 1 is equal to 8 minus 5 is equal to 3, see definition of delta 1. Delta 2 is equal to 8 minus 4 is equal to 4, see definition of delta 2. C is equal to 30.5 to 20.5 is equal to 10, see definition of C. Therefore, mode is equal to 40.5 plus parenthesis open 3 over 3 plus 4 parenthesis close times 10 is equal to 40.5 plus 30 over 7 is equal to 40.5 plus 4.285 is equal to 44.785. Thus, the most frequent number of participants is approximately 45 people. To calculate the median, we shall use equation 4.3. Meanwhile, the median occupies the n plus 1 over 2 position. 20 plus 1 over 2 is equal to 21 over 2, 10.5. 20 plus 1 over 2 is equal to 21 over 2, 10.5 position. Examining the cumulative frequency column 7, we found that
10.5th position falls in the 40.5 to 50.5 class, which is the median class. Median is equal to Li parenthesis open n over 2 minus summation fpm over fm parenthesis close c is equal to 40.5 plus parenthesis open 20 over 2 minus 7 over 8 parenthesis close times 10 is equal to 40.5 plus parenthesis open 3 over 8 parenthesis close times 10 is equal to 40.5 plus 30 over 8 is equal to 40.5 plus 3.75 is equal to 44.25, approximately 44 people. 3. To answer this question, we should bear in mind that the mean is the only measure of central tendency which takes all the observations into account in its computation. We are only fortunate in this example that the three measures happen to fall in the same class, 41 to 50. This may not always be the case. The mean 44 participants is the figure that best describes this distribution. Note, the relationship between the three measures is mode equal to 3 median minus 2 mean, 4.5. Summary. Descriptive tools such as percentages, ratios, rates, average, etc. are useful tools in comparative studies. The crime level of two countries can be compared when they are expressed as a rate per thousand of the population. The mean is a measure of central tendency which shows the typicality of its group. The mode is the most frequent occurring value, while the median divides a set of values into two equal halves. In the next lecture, we shall discuss the remaining aspect of descriptive statistics, that is, the measure of variations. This is the end of study section 5. Thanks for listening.